Lesson 6.5, Applying Systems of Linear Equations. Our essential question is, how do you determine which method to use to solve a system? Remember that we've learned 3 methods so far: graphing, elimination, and substitution. So basically we're asking you, if you're given a system, how do you look at it and figure out which one of those methods makes the most sense to use to solve that system? Because you can use any of those methods at any time. Sometimes one method, though, makes a lot more sense than the other two, meaning a lot less work for you. Okay, this is a review from 6.1, so a long time ago. We just want to make sure that you remember that there are 3 different things that can happen when you're given a system of equations. Most often, you find that there's one solution. That happens when your lines are intersecting. To describe the equations have different slopes. And here's a graph that shows 2 lines that are intersecting. The second thing that could happen is there could be no solution. That happens when our lines are parallel. Lines are parallel if they have the same slope but a different y-intercept. And lines are parallel when on a graph they never cross. The last thing that can happen is there can be infinitely many solutions because your 2 lines are actually identical to each other. They have the same slope and same y-intercept. They're actually the exact same line when they're graphed. So these are the 3 different types of situations that we can see. Okay, now, this next click and drag activity says choose the best method to solve each system of equations. First, I want to talk about graphing. In lesson 6.1, we solved systems by graphing. I prefer to only use the graphing method if my equations are both written in slope-intercept form. So what that means is, if I look at the 10 systems that are written over here, I'm looking for ones where both of the equations start with y equals. Because slope-intercept form, to me, is set up and ready to go for graphing. So I would always, if I had, well, I shouldn't say I would always, because I would actually use substitution on some of these, but if I was going to solve a system by graphing, this is the only type that I would consider graphing. They're written in slope-intercept form. Now, substitution from section 6.2. What I remember about substitution is you need one of the letters by itself. So it has to have an equation that says x equals or an equation that says y equals. Just one of them has to have a letter by itself. So this equation looks good to me for substitution. So does this one. And so does this one. They've all got one letter by itself. Whether it's x or y does not matter. And then elimination. When both of your equations are written in standard form, elimination is always the way that I go. So all 4 of these have the x's and y's lined up, the equal signs lined up, and then just a plain number, constant, on the right-hand side. So they're both written in standard form, lined up with the x's and y's. Those are set up for elimination. Remember, we're just trying to get you to understand which method is probably the easiest to use. If you really don't like using one method, you can always convert it into a different form to use one of the other methods. Okay, so now we're going to take 3 of them from the 10 that were on the previous click and drag and solve one of each. So this is one of the ones that we said I would solve by graphing. They're both in slope-intercept form. My red equation starts at an intercept of 4, and then that slope is -3 or -3/1. So I go down 3/1 to the right, and I can draw my line. The blue line starts at an intercept of -4, but the slope is still -3 or -3/1. So I go down 3/1, and I can draw my line. So these lines are parallel, so my answer would be no solution, because they do not cross. And remember, when we're asked to solve a system, that means they're asking us, where do they cross? So if they're parallel, they don't cross, you need to state that there's no solution. Okay, the next one. This one, I said I would solve by elimination because I have opposites. And I actually have opposites right away on this problem. The x's cancel out. If I add together 3y plus -5y, that would be -2y. And -3 plus 5 is +2. Divide both sides by -2. And my y coordinate is -1. So I have half of my solution. Now, to get my x coordinate, I am going to go with the bottom equation. 4x minus 5y equals 5. And I will substitute -1 for y. -5 times -1 is +5. So I need to subtract 5 to get rid of that. 4x equals 0 then, and 0 divided by 4 is 0. So my solution is 0, -1. My third example, this is the one that I would do substitution on, because x is by itself, it's equal to 9 minus y, so the other x is going to be replaced with y minus 9. I think I said that backwards a minute ago. Okay, so I'm going to take this top equation where the x is, I'm plugging in y minus 9, then I have plus y equals 15. Now it's ready to solve. 1y plus 1y. These are like terms, they're on the same side. So 2y minus 9 equals 15. Add 9 on both sides. 2y equals 24. Divide by 2. And y equals 12. So my y coordinate is 12. Now I'm going to take that y equals 12, and I am going to use the bottom equation. X equals y minus 9, but y is 12, so 12 minus 9 equals 3. So my solution to my system is 3, 12. For your summary, we would really like to see 3 separate sentences, one for each of the 3 methods. We'd like you to really think about how you figure out what you look for to determine which method you should use. And here are your homework problems. Remember, you get to choose your method,